Hi everyone, this is Miss Libby over at the Lodi Library. Welcome to our first STEM experiment. We will be doing these every other Monday at 3:30, and they will be uploaded here to YouTube at that time. So, why don't we get started? Our first lesson today is all about oxidation. And it's a big word, but I bet you've seen it before in your everyday life. So, the most common way of seeing it is, have you ever had an apple and after you cut it and leave it for a bit, it kind of starts to turn brown? Well, it turns brown because of oxidation. The outside of the apple protects the inside of the apple, but once you cut it, that protection isn't there any longer, and then the oxidation occurs because the inside of the apple is touching air, which has oxygen in it. So today our experiment is going to be how to stop or slow oxidation with science. One of the reasons that oxidation occurs is because it has an enzyme in it that reacts to the air, to the oxygen, and causes oxidation. One of the ways to prevent it, to stop it from happening, is with something called ascorbic acid. You probably haven't heard of ascorbic acid before, but you might have heard of its other name, which is vitamin C. So we have different liquids today, and we're going to test which liquids prevent the apple from oxidizing or turning brown the best. So I have salt water, sugar water, plain water, honey water, lemonade, orange juice, apple juice, and finally, pure lemon juice. So it doesn't have any of the added sugars and everything that lemonade has. It's just straight up lemon juice. Okay, so while we get started, I am going to have to cut our apples. I could not cut them ahead of time because then they would start to brown and our experiment wouldn't really work. So bear with me while I cut these apples. So I would like you to try this at home after this video, and at the end of the video I do have a list of the ingredients you would need to do this experiment. Okay, so I have my apple cut up, and I am going to leave one piece of apple outside of the water, so we have what's called a control, so that we can see what happens when we do nothing to the apple to prevent it from browning, so we can tell how the other liquids did based on what that apple did. So I'm going to put these apples in the water straight away because they are already starting to brown a little bit. And if it browned ahead of time, what's the point of our experiment? When you do this experiment at home, just make sure that the apple slice is completely covered by the water. Don't leave a little bit hanging out. And some of them may float, which kind of happens with apples, but we're gonna do the best that we can. It would probably be better if you did a larger apple slices, so they're heavier than I did. So I would suggest maybe using 2 apples rather than just the one. Okay, now I'm going to set this to the side, and what we're going to do is we're going to pause here, and I'm going to come back in 3 minutes to see how our apples are doing. So I will see you very soon. Okay, it's been 3 minutes and we are back. I'm not taking the apples out of the liquid just yet because we're going to take them out after another 3 minutes, so 6 minutes total. But I want you to see what's happening. So this is our control apple that is not in any liquid. And here are our other apples. You can see some of them are starting to brown a bit. Some of them sink to the bottom, some of them aren't, so that'll be a factor in the oxidation, but they have all been coated with the liquid. So, as you can see, our control is getting much browner than the other apples that are sitting in the liquids. So, I'm going to pause here, and we'll come back in 3 more minutes and take the apples out of the liquid and see what happened. What I want you to do is pause the video, write down what you think is going to work the best. Now remember, I said vitamin C is ascorbic acid, which helps slow the oxidation process. So think about what has vitamin C in it, what is kind of acidic, and what has sugar in it, because sugar might make a difference. So I want you to make predictions. Okay, it's been another 3 minutes and our apples are ready to take out of the liquids. So I'm going to do this handheld, so if it's a little shaky, sorry about that. But I'm going to take these out one by one so you can see. There is the pure lemon juice, the apple juice, orange juice, lemonade, salt water, sugar water, plain water, and honey water. Okay, so take a look at these. Which ones do you think did the best job? So look at our control. This was not in any liquid. And then look at the others. Which ones are the least brown and which ones are the most brown? So I would say the least brown ones are the pure lemon juice and the orange juice. Close second are the apple juice and the lemonade. So what's interesting about the apple juice is if you do this experiment, I want you to pay attention to your bottle of apple juice. Ours had added vitamin C, which we spoke about earlier, helps prevent oxidation. If you have apple juice that doesn't have that added vitamin C, you'll probably get a different result than I did. So I don't think the plain water or the sugar water worked very well. The salt water and the honey water did a decent job. And I want you to take a look at the lemonade and the pure lemon. So they both have lemon juice in them. They both have vitamin C, but one worked better than the other. Can you think of what makes lemonade different from pure lemon? It has sugar in it, right? Now take a look at the sugar water compared to the salt water. The sugar water one is browner. So we can infer from that sugar does not do much to prevent oxidation. But the things that had vitamin C or ascorbic acid in them, the orange juice, the pure lemon, the apple juice, the lemonade a little bit, did very well at preventing oxidation. And the saltwater one also did a good job, and salt has been used for hundreds of years to preserve things. So that's not too surprising. Okay, so our experiment is over. If you took predictions, I want you to take a look and see if your predictions matched up with what happened. And if they didn't, that's fine. That's why it's an experiment. We don't exactly know what's going to happen. So if you try this experiment at home, I want you to do your predictions again and see, after seeing it for the first time, if you're correct the second time. Okay, and we don't really like to waste food around here, so I'm gonna have some apples.